So, we're going to look at the first problem here. And I'm actually going to, well, I'm not going to highlight anything. I am going to get a piece of paper out, though. So, we can actually see what we're doing here. All right, now, consider the following reaction. I'm making a video here. Alright. Alright, we have 2 aluminum plus 6 HBRs. I think that's bromic acid. It's going to yield 2 aluminum bromines and 3 hydrogens. Alright, when 3.22 moles of aluminum react with 4.96 moles of HBr, how many moles of H2 are formed? So that's our first question. Now, the biggest thing here is we have to calculate the limiting reactant. That's what's going to be the key to the whole problem. So, I want to take 3.22 moles. You can write them right on there. Can we write it on that? Sure. Work with this one first. Then I'll give you another one. Alright, so there's our mole ratio. Alright, now what I want to do is I want to make this mole ratio into something that looks a lot like the mole ratio from our problem, from the actual equation. The actual equation is it's 2 aluminums to 6 bromic acids. Alright, so here's what I'm going to do. I'm going to take this guy, I'm going to divide. What should I divide by? Yeah, 4.96. Divide that by 4.96 because I'll get a 1 in the denominator. And so I'll take 3.22 divided by 4.96. And it'll be 0.649194, and that would end up being 1. So that's moles of aluminum to 1 mole of HBr. Now, I'm going to do something weird here. In order to make a good comparison, I need at least one of these numbers to match up. So I need either the top number or the top number to equal the top number, or the bottom number to equal the bottom number. So which one's going to be the easiest one to do? Bottom. I'm going to multiply that by 6 and that by 6. And the only reason why I'm doing this is if I multiply the top and the bottom by 6, it's really times 6 over 6. What's 6 over 6? 1. So am I actually multiplying by anything? No, I'm multiplying by 1. So that's one of the mathematical tricks that are out there that will allow you to do pretty much anything you need to do. So this is going to give me 6 moles of HBr, and then I'll take the top, I'll get 3.89516 moles of aluminum. Now, I need to compare. This is the actual, and this is the given. The given will give me 6 moles of HBr, but it also give me 3.895 moles of aluminum. Now, if I use up 2 aluminums, I'm going to use up 6 HBRs. So if I use up the 6 HBRs, I use up 2 there. Is the HBR gone? Is this gone? No. So there's more of the aluminum left over. So what's going to be my limiting react? What's going to stop first? Yeah, this guy is going to be my limiting reactant. This guy is going to be the excess reactant. Now, what we have to do is actually use that amount, because that's the amount that we were actually given. Now, so we already figured out the limiting reactant. That's HBr. And that's by actually taking the mole ratio and doing a little division and multiplication to make it look like at least one of them is here, and then you can make the determination based off of that. Just remember, one of them is going to stop first, and you got to determine which one is going to stop first. Then part C, the last part here, says what for the reactant in excess, how much, we have to finish part A because we never really finished part A. We figured out part B because that's the one that's the most important thing. We have to figure out the limiting reactant. But now it says how many moles of H2 are formed. Well, how many moles of HBr do we start with? Alright, so we start with 4.96 moles of HBr. Now, how many moles of HBr? We're going to convert moles to moles. So, 6 moles to how many moles? 6 to 3. So 6 moles of HBr to 3 moles of H2. Now, all it asked for was how many moles of H3 are there, or H2 are there. Those divide out, those divide out. Do I have enough in the unit analysis to figure out how many moles of H2O or H2 are there? Yeah. So I'm going to take the 4.96 times 3 divided by 6, and I'm going to get 2.48 moles of H2. So that tells me that 2.48 moles of H2 are actually going to be produced in that point. So that's a little bit easier because we don't have to do the molar mass conversions and all that. Now the last one says alright, how much excess moles are there? So part C says, for the reactant in excess, how many moles are left over at the end of the reaction? So let me kind of move this over here and say for part D, sorry about that, for part C, how many moles of HBr are used? Now, I need to go moles to moles. So, if I use that moles, I have to use the mole ratio of 6 to 2. So, I know it's going to be 6 moles of HBr is going to use up 2 moles of aluminum. So, I'll use my calculator again. 4.96 times 2 divided by 6 will give me 1.65 moles of aluminum that is used. now I got to do this. We have given and we have used. How much was given? How much aluminum was given? 3.22 moles of aluminum. Right here. That was what was given. How many did I use up? That's how much was used. 1.65 moles. So how am I going to figure out how much is left over? Yep. I'm going to subtract these. That's a 1, so that's 7, that's a 2, that's a 1, that's a 5, that's a 1. So I subtract that, and I get 1.57 moles that are left over. Alright. That's how you do number 1. And guess how you're going to do number 2? The same way. What about number 3? Number 4?